In this lesson, I'll show you how to solve trigonometric equations with multiple angles and special triangles. This is part 2. Question 1 reads, solve the equation 4 times cosine squared x minus 3 is equal to 0 on the intervals between 0 and 2 pi. The first thing that you'll notice is this equation models a quadratic, a pure quadratic. For example, we have 4 cosine squared x is equal to 3. Think of it like this. 4x squared is equal to 3. A pure quadratic is one that has the a term and a constant only, and it can easily be solved by dividing both sides by 4 and then square rooting to get your x. But of course we're not working with x, we're working with cosine. So let's keep that in mind. We have 3 over 4. I'm dividing both sides by 4. Gets rid of the 4 on the left side. This leaves us with cosine squared x on the left side. Now we take the square root of both sides. If we do that, we end up with cosine x is equal to the square root of 3 over 4. Square rooting a positive number will give you a plus and minus version of that number. So we have cosine x is equal to the square root of 3 over the square root of 4, that's 2. This will be plus, and cosine x is equal to the square root of 3 over 2, and this will be minus. There is a special triangle with these two numbers, and it looks like this. We have pi over 2 in the corner, that represents your 90 degree, pi over 3, and pi over 6. The one across pi over 3 is the square root of 3. And the one across the smaller angle is 1. The hypotenuse is 2. Also, cosine is positive, if you look at the cast rule, here, represented by all, and here. It's negative here and here. This means that we're going to have up to 4 angles that represents this equation. Cosine is a ratio between adjacent and hypotenuse. So taking a look at our special triangle, we have to determine which of these two angles will give us the square root of 3 over 2. And given that cosine is adjacent over hypotenuse, this is your adjacent and this will be your hypotenuse. So this is our reference angle. So our reference angle is pi over 6. That also serves as one of the angles for this equation. To find this angle, we take pi and subtract it from pi over 6. To find this angle, we take pi and add it to pi over 6. And to find this bigger angle, we take 2 pi and subtract it from pi over 6. Our 4 angles will be pi over 6. This becomes 5 pi over 6. This becomes 7 pi over 6. And for this, we have 11 pi over 6. Now let's move on to question 2. Question 2 reads, solve the equation sine x tan x is equal to sine x on the intervals between 0 and 2 pi. Let's rewrite that underneath. Sine x tangent x is equal to sine x between 0 and 2 pi. Now you'll probably be tempted right away to divide both sides by sine x. However, by doing that, you're missing out on some essential angles. So there's a better way. Instead, take this sine x to the other side. We have sine x tangent x minus sine x is equal to 0. As you can see, a common factor between these two terms is sine x, leaving you with tangent x minus 1. I'll set sine x equal to 0 and tangent x minus 1 equal to 0. Bringing this negative 1 over, we end up with tangent x is equal to 1. I'll highlight these two. Now, when is sine x equal to 0? Let's take a look at a wave. Sine starts off at 0 and 0, then makes its way to a maximum, and then back down to 0, minimum, and the cycle ends. Therefore, sine is 0 at angle 0 and at angle pi. We just found two angles for x. We also need to find two more for tangent. To figure this one out, of course, you can use a special triangle, and the one that I will use is the one that relates the square root of 2, 1, and 1 for the angles pi over 4 and pi over 4. Tangent is a measure of opposite over adjacent. You can choose any of these for that. Opposite over adjacent, 1 over 1. Therefore, x is equal to pi over 4. And given that tangent is positive, in quadrant 1 and 3, we can find the third one by adding pi to this. So if we add pi to pi over 4, we end up with 5 pi over 4. So x is equal to pi over 4 and 5 pi over 4. There you have it. That is how to solve trigonometric equations with multiple angles and special triangles.